I'm
All
not
right.
really certain how long it takes different teachers to grade different things. So I just like whenever I see that something hasn't been graded after a while, I'm like, is it? Just
If it's
in the
not
type?
graded, don't worry about it. It will be graded before your actual grade is turned in.
All right.
If it is graded and you get a 0, then it's a different story. Then that means that there's either a reason that you're getting a 0 or I misgraded it, and that's why you're getting a 0. If it's just blank, that means I have not gotten around to it
I
yet.
definitely got it better than a 0.
Okay.
Didn't do it perfectly, but did better than 0.
What happens if you print a number separated by a mathematical operator and a string?
Well, let's get to that part. Okay, so I'm starting my recorder right now, so we can actually talk about it. All right. So I made an error.
It's not due yet.
Okay, so I made an error in the current homework assignment, and I just kind of want to point out where the error is. I have since re-uploaded the document, so if you have not started yet at this point, the document that is on Moodle is already corrected. Okay, it has to do with this last part here. This part was an x before, okay? Now the way it is, if I make this an x is not a local variable, so it has to be a global variable. And I never tell you what x should start with, and there's no assignment statement to x. That means x as a global variable has an unknown value. If you add a known value to a known value to an unknown value, the sum is still unknown. So that's why this program would not work the way it is, and you have to basically say, okay, it's going to print unknown. You can resolve the first invocation, you can resolve the second invocation, but by the time you get to the third one, it's unknown. So you have to basically say the whole thing is unknown. So that's why it's my mistake. I was confusing myself. I thought x was my local variable name. It's actually I. So this is the correct version of the homework, where you're just using I as the local variable in this case. So in this case, you can definitely resolve the value of the entire expression. And remember what I said in class, you have to evaluate this from left to right. Okay, so you have to deal with the first invocation to post-inc or post-increment first, and then you deal with the invocation to pre-dec or pre-decrement, and then you add the value of I after the 2 invocations to the subroutines. Now, the tricky part about this is I was passed by reference to post-inc. It was also passed by reference to pre-dec. So that means, every single time you invoke a subroutine, it can potentially change the value of I. And then when you get to the second invocation, you have to remind yourself to use the latest value of I because it is passed by reference. So as long as you kind of keep track of all that stuff, it's not really particularly long. I think the trace is not really that bad. It's just, can you kind of figure out which column we're dealing with and update the right column the whole time. Yep.
Was there 4 columns that we needed?
Let's see.
Besides not including comments and what?
Well, you need 2 columns to invoke main, and then from main you have to invoke post-inc, which takes up 2 columns. So yes, you need a total of 4 columns to finish the entire thing. Now the 4 columns, 2 of the 4 columns will be deallocated and immediately reallocated. Okay, so you have to kind of keep that in mind too. Okay. Any other questions about this particular assignment? Nope. Okay. So if there are no questions about this, I'm going to close it. I'll see it anyway, just in case. And then we can continue our discussion of types and records. And this is this is the notes on types and records. Last time we talked about what a record is already. It's kind of like a record is a user-defined type basically. It's a template. You can look at it as a cookie cutter. And then what you can do with a record type is you can use the cookie cutter to cut out cookies. The cookies in our cases would be our variables, parameters, and so on and so forth. So let's go ahead and try to use types and records for a few sample programs. We did some sample programs already, and we can do a little bit more today. Are there any general questions about what a record is and what it can be useful for? Nope. You can have a record inside a record. Okay, so let's go ahead and see how we can have a record inside a record. Okay, so I'm going to define a record type for coordinates first. Okay, so coord is the name of the record type, and you can see that as a convention, it is not a requirement, but as a convention, the name of a record always starts with an uppercase. That's also a convention observed by most C, C++ programmers. So X is an integer, Y is an integer, and record. All right, so this is remember, this is a cookie cutter. It is not, a variable, it is not a parameter, it is just a user-defined type, and I have not really used this, cut out any cookies at this point using this. And then the next thing I'll do is I will define, let's say a single point, okay? A single point that you can draw or paint on the screen will contain a coordinate, okay? So I will have a member called C, and C is of the type coord. I can have, let's see here. I probably want to define a color too, so let me just go ahead and define some colors. This is one of those, sample programs where I will reuse it a few times because, it can help me illustrate different types of concepts. So I will have color, and let's just say that I use the RGB method to represent color. R stands for red, G stands for green, and B stands for blue. Just like that. So when I want to represent a point that I'm painting or drawing on the screen, I have C as coordinate, and I cannot use C again for color. I can always use lowercase color as the name of the member, and then use uppercase color as the type. And record, just like that. Are there any questions at this point? So when you look at point, it is not, each member of point is no longer a single type, because the member C is actually itself a record, and then the member called color is also itself a record type. Okay. So at this point, let's just take a look at, how do we allocate a variable of the type point. Okay, that's all we want to do at this point. Okay, so we'll define a subroutine called main, and then inside main we'll just allocate for a variable like this. So we'll just say p local p is a local variable called p, and it is of a type point. And let's not even do anything else, okay? Because at this point my focus is really just how do we allocate something like this. Okay. You guys have any questions that I can answer? Okay. All right, so let's go ahead and trace this particular program. It's not going to take long. This is a really short one to trace. It doesn't do anything except to allocate some columns and then immediately deallocate the columns. But it is still useful because we want to see exactly how the columns are being used when we have a local variable like this. We don't have we do not need comments because there are no conditions to evaluate, and there are no print statements. So we can just start with the line number. The precondition doesn't have anything to say because there are no global variables. And then we start on line 17, the first line, the only line that is outside of the definition of any subroutine. It needs a return line number to get back to post. And now we have to allocate for the local variable. Technically, there's only one single local variable. It is p. Okay, p is the name of the local variable. On the other hand, but P has different components. P has two components. The first component is called C, it is a coordinate, and then the second component is called color. So P now has one component called C, and then within C, we have, which is a coordinate, it has two components called X and Y. And then the other component is color, and color has R, G, and B. So if you look at P as a whole, it is referring to all 5 columns. When you look at P dot C, which is the member C of P, it is referring to these columns. When you look at P dot color, it is referring to these 3 columns. So are we doing okay so far as far as the layout of memory or columns are concerned? Now, because this is a local variable, every single column starts with a question mark. Like that. So are there any questions at this point about how we use the columns to represent a record variable called P?
And the question marks are because it's a local, so all of those extra components become question marks. Right?
Well, whether it's local or not doesn't matter, because even with global variables, unless I give you a precondition, a condition, and say, okay, you can assume blah, 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 they all start with unknown values. Okay? The only time they do not start with unknown values is when you have a pass-by value parameter. Then you start with specific values.
Any one of those could have been passed by value too.
You can pass an entire record type by value because it's just a copy of whatever you're passing to it. Yep.
So you put you specify the X, Y, R, G, and B are all integers. What would be the other option of putting there? Like you say X colon integer. What do you always have to specify integer? And
right.
If you aren't specifying integer, is there something else to
That's a good question.
specify?
Okay, that's a very good question. The question was, I always put integers here, 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 and here. So the question is, are there alternatives other than integers? What else can we put there? You can also put what we call a floating point number, so it can represent real values. You can also put in different types of integers. Okay, so this is it's gonna go in I'm gonna take the class to a little digression because I think it is a very important digression because I'm kind of glad that you asked that question. What is an integer? In a mathematics class, and you ask the professor what is an integer, what would be the answer? Whole numbers, but whole numbers usually just refer to one side of the integers. So when you look at integers, it is both positive and negative and also 0 itself, right? Yeah. Because whole number, I think, depends on the definition. Some people look at whole numbers and they only count from 1, 2, and 3, and up. And some people count 0 also as a whole number. Natural number starts from 0. I know that one for sure. And then integers, go both in both directions. Okay, but they definitely have to be, whole integers. They cannot have fractional parts. Okay. So in addition to integers, you can also have what we call floating point numbers or real numbers. Okay. In a math class, what is a real number?
It's not a negative number as the square root, right?
Okay.
not
So you're
imaginary.
not imaginary. You're talking about not imaginary. Okay. So in a math class, the set of all integer numbers is represented as an I, but written in a kind of funny way. Okay. The set of all real numbers is kind of written kind of like this, and this is a subset of that. In other words, all integers are real numbers too, but real numbers also include, all sorts of other things. Like, 22 divided by 7 is a real number, but it is also called a rational number, okay, because it can be represented as a fraction, okay? But what this usually is used for is to approximate pi itself. But pi is not a rational number, but it is a real number. Okay, so we're talking about these things which is this is 3.1415 blah 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 blah. So these are basically real numbers. 3.1415 blah 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 is definitely not an integer. Okay, so why do you think that we sometimes need to represent values like that instead of just integers?
Constant.
Well, imagine you're playing maybe a video game. Okay, so what do you think in a video game that requires a representation that is not inherently an integer?
Any kind of graphics, like curves or spheres.
Okay, or location of objects. Okay,
Physics within a physics engine.
within a physics engine.
Just
Yep.
for like the matrices of the game.
Right, and also the rotation, okay, of objects. That's not always representable as an integer. So that's why in addition to integers or the ability to represent integers, a computer can be useful if it can also represent something that looks like real numbers. Okay, there's no way to store even 22 divided by 7 exactly in a computer. They can only store an approximation of 22 divided by 7, let alone a irrational number like pi or e or stuff like that. Okay. So the next question now is, okay, this is in theory, okay? The set of integer value is in theory because there's no end to the set of integers. What is the largest value in the whole set of integers? Or what is the largest integer? There's no such thing, okay? Because if you tell me that n is the largest integer, then I will ask you what is n plus 1, right? So that's nice in a math class, but in the computer programming class, that's a problem.
I can only go as far as operating system reference numbers.
Or as long, you have to kind of limit how many bits or how much resource you allocate to represent numbers. Does that make sense? How much RAM does your computer have? Gobs, okay, 32 gigs, okay? Some people can say, I got lots of RAM in my computer. The next question is it finite?
Yes.
Yep, it is still finite. Okay, so that's the whole problem. You can add as much memory as you want to a computer, but in the end, it is still finite. There's still a limitation. Okay, which means even if you use all 32 gigabytes to represent a single number, there is still an upper limit of what value you can actually represent using every single bit of your entire system.
Wouldn't it be like half, like for the positive side, it'd be like half of 32 billion minus 1, and then the negative side would be
It's 2 to the power of 32 billion minus 1, which is really huge, but nonetheless, it would not be able to represent the next value. so you're still running up against the limit. So that means when you look at integer as a math concept, when you translate that into computer programming, it is no longer a clean concept anymore. Okay, so you'll be looking at what we call 8-bit, 16-bit, 32-bit, and 64-bit. Well, we mostly only work up to 64-bit integers. In other words, with an 8-bit integer, we're only allocating one single byte of computer memory to store the value. With a 16-bit integer, we're allocating 2 bytes. 32-bit, we're allocating 4 bytes, and 64-bit, we're allocating 8 bytes per integer. Okay, so that means even though in this particular pseudocode it looks really clean, it's just integer. When you are in the C and C++ programming, you actually have to think about, okay, it is an integer, but how many bytes am I allocating to X, Y, and an RGB? Yep.
So you could break this algorithm if you enter a number that
Cannot be represented based on the limitation. That is correct. There's a limit, and if you exceed the limit, sometimes you do not get any warning whatsoever. The program just stops behaving correctly.
But as it is represented right now, if you just say integer, you can only have 1 bit per number, right?
No, when you just say integer, that's the theoretical integer where there's no limit. But when you're actually programming in C and C++, when you say integer, it is already implying a width, how many bits are actually allocated to represent integers. I think the current standard is if you say an integer in C and C++ programming, with most compilers it is implied to be 32-bit. Okay, now 32-bit sounds like a lot of bits. Okay, 2 to the power of 32 seems like a large number, but it's not. It's only up to 4 billion. Okay? And it's not a big number. 4 billion is really not a big number anymore.
And that's why you now have 64-bit operating systems.
Just think about the hard drive space, okay? 4 billion is 4 gig. Okay? How many people are still using a 4 gig hard drive? when was the last time you see a 4 gig hard drive?
When's the last time you seen a 4-gig flash drive?
I still have 2 in my box.
You can't buy them. Like,
yeah, you can still buy 4 gig. I think 2 gigs are out, but you can still buy 4 gig.
I don't know, does a 4 gigabyte hard drive count as a paperweight? Does a paperweight count as a first time I saw it?
If you want paperweight, you have to go back to the old, SCSI drive, the full height, 5.25-inch drives. Now, those are boat anchors.
I saw a picture of a 512 megabyte drive that was the size of a full-size washer.
Yeah.
That was back in
It was
1968.
probably one of the first hard drives, for IBM mainframes. Yep. So anyway, so that means 32-bit is not really that big of an integer. Okay, you run up to its limits really quick when it's a 32-bit integer. 64-bit takes a little bit longer. Okay, because you're talking about 2 to the power of 64 minus 1 as the largest positive value that you can represent. Okay, so that's a very good question. Now the next question is, how do we represent things that have fractional values or 0.0001? How do we represent values like that? Okay, in a computer, what we understand as real numbers. Okay, so integers gets translated into integers of different width. Real numbers map to what we call floating point numbers. So we have what we call IEEE floating point numbers. And there are mostly 2 of these. Okay, I think there are more than that, but these 2 are the most common types. The first one is called a single precision floating point number, and then the second one is called a double precision. It's a little bit beyond the scope of this class to actually talk about the representation, but inside the representation of a floating point number, it's really just an integer with an exponent. So you're talking about just a regular integer times 2 to some kind of exponent, and that's how we represent decimal, fractional values or floating point numbers. And that's so that those are the actual real choices when it comes to the actual type of a number. You can choose between different types of integers and also floating point numbers. Okay. So that was a good question to ask. All right. So do we have any questions up to this point? What if I want to initialize just column D? How do I refer to column D? In other words, if I want to insert one more line of code here, and I want column D to get a value of 3, okay? What should be the left-hand side of this assignment statement? Well, first of all, which variable owns column D?
1.
Which variable? We only have one variable of the entire program up to this point. It's variable P, okay? P is our only variable, okay? But P refers to column C to column G. Okay, so what is the next step to kind of narrow down to just column D?
What record of 1?
The which member of P owns column D?
C.
Column, yeah, exactly. Member C of variable P owns this column D. Okay. So within P dot C or member C of variable P, which one owns column D?
1.
Y, exactly. So the way to refer to that column inside the subroutine here is we're referring to variable P, and then the first part is member C, and then the second part is member Y. Okay, so that's how we refer to a particular column, so you can actually change the value of a single column.
Just like IP address.
Hmm? It looks a little bit like IP address because of the dot.
It's like an array.
It's not an array, it's not an IP address, because in this case, you can only get to a member by its name, but you cannot get to it by a number.
Okay. It's like an array. It's just like, 'cause you're
It's a composite.
Yeah.
Yes, it is a composite, but it is not an array in the sense that you cannot index into a particular part. And that's a big deal, because the whole thing about array, or the nice part about an array, is you can have one single statement, but by changing a variable, by changing the index inside the square bracket, you can use the same statement to access different parts of an array. You cannot do that with a record, because it's only done by name. So this line here, okay, let me just renumber the lines so I can refer to the line numbers correctly. And obviously the other part has to change too. That's an easy change. Okay, so when you look at something like this, and on line 16, line 16 can only refer to a particular item inside variable P. It cannot refer to something else, because there's no indexing concept, there's no square bracket, and you cannot change the values inside the square bracket. And that's why it is an entirely different concept from that perspective.
Is there a way to make an array called values, not values, variables, and then assign each of the variables a name in that array, a number in that array?
You can accomplish an effect like that by using two arrays, or you can use an array of records. So, okay, so let me see if I can understand. See if this is what you want to do. Okay, let me save this document first. So let me see if I'm understanding your idea. Okay, so what you're talking about is, I can make a record, it's no specific name. Okay, I'll just call it an item. Okay, so of an item, you have, a name, which is what we call a string, and it has a value, which is an integer. Okay, so I have to stop right here and just kind of explain what a string is. A string is basically a type that can store text information. Okay, in other words, with an integer you can only store values, numerical values, 1, 5, -10, and so on. A string, on the other hand, can store any type of text information. You can store a name, you can store a city name, an address, and so on and so forth. Okay, so what you're talking about is the association of a name with a value. So in this case, we can combine the two concepts. We can combine the concept of a record with the concept of an array. So we'll just kind of make a very simple exercise out of this. Define main subroutine main. And inside main, I can have local variable. Let's call this A, and this is an array of, let's say, 3 items. Okay, I know it's bad grammar, but it's just the syntax to indicate that this is an array, and then each item in the array is of the item type. Okay. Then what you can do is to say, a bracket 0 dot name gets, in double quotes, Tom. Okay, and then you can have a bracket 1 dot name gets Jane, and then a bracket 2 dot name gets Michael. Are we still doing okay so far in terms of the concepts? Because this is the first time we combine the two concepts together. We're combining the concept of an array with the concept of a record. But is that okay, or when we trace the algorithm, it will be very clear how everything is actually represented. So this is still okay so far? All right, so the next thing we can do is to give the values, something. So Tom, let's say, has a value of 5. And Jane has a value of 10. And then Michael has a value of 3. Okay. So let's just stop here, with this particular code, and then we'll do a simple trace and find out, what it looks like. And then we'll talk about, how can something like this be useful? Why would this be useful at all? Okay, so ND find sub. Okay, when you trace something like this, we just have line number. There's nothing to say about the precondition. There are no global variables. On line 14, we invoke main. When you invoke main, the simplest column to set up is the return line number. It is just going to go back to post. And now, how do we allocate for local variable A? Now, A is kind of interesting because A has 3 items. Okay. So it seems like, well, we'll just allocate, 3 columns. But that's not true because each item has 2 members, okay? And in this case, I'll just make it like this, okay? A bracket 0 is going to take up 2 columns, A bracket 1 takes up 2 columns, and then A bracket 2 also takes up 2 columns. Within these 2 columns, one is called name because it's a member of an item, and the other one is called value. Name, value, name, value. Okay, so let's shrink the columns a little bit so we can see a little bit more, just like that. Now, because this is a local variable, they all start with unknown values. And if I want to make it very clear which 2 are one single item, I'm going to merge the cells so it's clear, when we refer to A, we're referring to all 6 columns. When we refer to A bracket 1, we're referring to column E and column F. When we refer to A bracket 1 dot name, then we're referring to just E. Are we still doing okay so far with this code? Okay. So when you look at the inside the subroutine starting on line 7, the rest of the program is to be fairly simple. This is A bracket 0 name, which is referring to column C. So column C will store, the string Tom, T-O-M, Tom, and then the next one is going to be Jane, and so on. The rest of the program is not very interesting. It's just a representation that is interesting. Yep.
Don't we have to, or wouldn't we have to say that that is a record called item, like A bracket 0 is a record item, and then it includes the string, or is it two values?
Well, A bracket 0 is already designating, already has a type associated with it, and the type is an item. So item is never represented in the columns. Okay. Because item is just like integer, it's a type. So and you never see integer represented in the column. Because the type is dictating where you can use it and how you can use it. But it doesn't take up storage. It doesn't take up any space.
It's just designated in the program itself.
Yeah, it's just basically what you can do with it.
So with this format, would you be able to say print a dot name and have it go through the array?
No, you cannot. Okay, I can see what you mean because you want to basically say a dot name, and then it will automatically refer to column C, E, and G. You cannot, there's no way, no easy way to do that.
Okay.
Yep.
Would you have to specify, you have to go into your A, and the first name will go to the next one, or go to the next one, but you have to use a variable.
Right, you have to basically use our usual way of going through an array in order to get through all the names of different items in the array. But that's a limitation of C and C++. In other programming languages, you can, like in PHP and Perl, and in most scripting languages, they have a concept called a hash. Basically, it's a map. So in those languages, you can associate a key with a value. And then there are special ways to extract just all the keys of a hash. With both Perl and PHP, I know for sure you can do that. I think with Python you can probably do the same thing because these languages are very competitive, so they have very similar features. But in C and C++, there's no easy way to do it.
Sounds like username and password stuff. Just reminding me of username and passwords.
Yeah, username and password, it's a typical thing. You use the username as a key to retrieve the password, which is a value, right? But in C and C++, once again, there's no built-in ability to do something like that. But you can do that in PHP and Perl, and most other scripting languages can do that too. I believe VB does not have a native ability to do that either. Okay.
Is it possible to modify a language?
What do you mean by modify a language? See, that's a very vague description.
Well, you say C doesn't have the ability to do something, so could you add that functionality to it?
You can add different types of records, okay? Because remember, records are user-defined, so you can define any record you want. You can also add subroutines to C and C++, so you can actually accomplish something like what she was talking about, okay? But not using the built-in types of C and C++, because you cannot change that. The built-in types are, basically hard-coded, right? I mean, it's determined by the standard. But on top of the built-in types, you can define your own types, and then you can define your own subroutines to accomplish what you need to do. So from that perspective, it is expandable, but at the same time, you cannot, have a new language construct to do a particular thing because you're not changing the language itself. You're just adding your own definitions of records and subroutines.
So there are other libraries for C++, right? There are other libraries, external.
Yeah, there's a huge library. There's a huge selection of libraries where subroutines are already pre-done, and all you have to do is to say, oh, I want to use that subroutine in that library. Yeah.
It exists.
Yeah.
But that's really not changing the native support of the language. That's
No.
just user-defined stuff that people have compiled into a library.
Right, exactly. It's basically you find user-defined stuff that somebody else has done, so that you can reuse whatever somebody else has done.
But you can't change the base functionality of a language without changing its compiler, correct?
Correct. That is correct. Yep. So is that answering your question? Okay. Now, with an array like this, you can search by name or you can search by value. Okay, because the name, you can basically have the linear search or the binary search algorithm, but only to look at the name portion of an item in an array and use it to locate the value, or vice versa. Okay, but you do have to make sure the array is sorted based on what you're searching for. In other words, in this case, I have two possible ways of sorting array A. I can sort it by name, or I can sort it by value, but not both at the same time.
Seems like it would be useful for like students and student ID numbers.
Yeah, but looking up actual things, we usually do not use the concept of an array to do it. We have what we call different types of data structure, for that kind of purpose. All right. So are there any questions about this particular example? I'm not going to finish it because the rest of it is kind of boring.
We don't care how long the strings are, right? Like Tom and Jane and Michael.
Well, that's another thing that is kind of complicated, because when you look at all the different names, Tom only has 3 characters. When you look at Michael, it has 7 characters. So how can we put 7 characters onto one single column? Okay, so internally, that's not really what's happening. Okay, Michael actually takes up more resources to store compared to Tom and Jane. Okay, Tom requires it requires 4 characters because there's TOM. Okay, and then but in C and C++, you also need something to mark the end of a string. It's called a null terminator. So that's why Tom requires TOM and then plus the null terminator. So it takes up 4 characters or 4 bytes. Michael, on the other hand, will take up 8 bytes. Okay? So the actual internal representation of a string is not truly represented by our columns here, but it is okay to look at it this way, at least in this class. By the time you get to the next class, when you get to the C and C++ class, then you will start to realize a string is nothing more than an array itself. Okay? The string is really an array of characters when one item is representing one single character. Yep.
So in like a 32-bit operating system, you can only represent a string that's 4 billion minus 2 because you need the null terminator. So like if your string was, 303,999,998 long, the null terminator would take up the last one, which would be 4 billion minus 1.
It will be 2 to the power of 32 minus 1. Yeah, because 2 to the power of 32 is a little bit more than 4 billion. But yeah, but you're correct. You can only use that number minus 1 for the actual name because you need the last one as a terminator. Yeah. All right. Well, since we're here already, maybe I should talk about the concept of ASCII code and how we actually represent characters. Yep, go ahead.
You keep saying strings as characters. I'm assuming you're including numbers as that, as it reads the numbers as characters, when like an address or a zip code.
Okay, well let's talk about that. Okay, so I'm going to talk about that with another program. So we'll store this one first. We'll call this record 2. Okay, so the next program is going to represent what is a string. Okay. So we have to introduce the concept of a character. So this is going to be a fairly simple program. Define main, define sub main, and I don't even have my own record type in this case, okay? Because this is what we'll do. This is local array A, and we'll just call A an array of 5 characters, or 5 chars. Okay, so A bracket 0 gets something, A bracket 1 gets something, A bracket 2, A bracket 3, main. I'm just making the template of the subroutine first, and then we'll deal with the rest a little bit later. Okay, let's trace it. Yep, go ahead.
Would you need one more for A?
Sorry?
Would you need one more?
Yeah, well, technically I do, but but in this particular example, it doesn't matter what I put over there. Okay. So we can trace this program up to a certain point, and then we have to stop, and then talk about something. So the precondition is nothing. We are invoking main on line 8. The return line number is post. So this stuff is pretty easy. And now we have the question of, okay, how do we represent local variable A? Well, A is it takes up 5 columns. So each column is representing one, what we call character. And you are absolutely right, there are 5 columns. So it goes up to A bracket 4. And just like any local variables, every single component starts with a question mark. So this part is pretty universal. We can track it down all the way up to here. And then we have to stop, because what if I tell you that I want the array A to represent Tom? Okay, uppercase T, lowercase o, lowercase m. Okay, that's the name that I want to represent using an array of 5 characters. Now, before we go any further, the first thing that we have to understand is what exactly is a character? Well, actually, we have it on the whiteboard already. Okay, a character is really basically an 8-bit integer. Okay, now that is actually changing too, because we used to only use 8 bits to represent a single character, but now because of internationalization, we use Unicode, and Unicode uses 16-bit. Okay, so we are actually slowly shifting a character from 8-bit representation to a 16-bit representation. Okay, but before we even talk about that, let's think about what a character is. Okay, why do we need something, of that type? Just kind of go back in time and say that, okay, I have a dot matrix printer, okay, and I want to print a number on the printer, or I want to print a name on the printer, Tom, T-O-M, okay? So I'm going to a console. Okay, this is the nice thing about Linux is, I can do something like this. I can basically say echo Tom pipe to LPR. This will basically send, the string Tom to a printer, the default printer, and print it out as TOM on the printer. So the question now is, how does this happen? Okay, if you just kind of forget about networking protocols and serial port and parallel ports, all the nitty-gritty details, what information is being sent to the printer? What is the bottom line of printing Tom on a piece of paper?
But you have to send the coordinates of where it should go, so you have grid patterns, say top, say grids are turned on.
What if you have one of those really, really old printer where it's more like a typewriter than anything else? Right?
You have
Okay.
to tell it what spool. If it's like one of those old printers, it's just like it has a spool with the
this
letter.
command will work with any printer. It will work with those typewriter type of printer. So
on the old ones, on the old printers like that, like you have to tell what spool to turn to what letter to print that.
okay, you may or may not have to get to that level. Okay, so when you look at the communication between the computer and the printer, what does the computer want to send to the printer in order to print TOM on a piece of paper, regardless of the printer technology? Okay. Okay, they all have to boil down to zeros and ones. Okay, very good. Okay, that's the very first observation. Is TOM has to be boiled. We have to boil it down to zeros and ones at some point. Okay. Okay. Well, how do you look at the uppercase T and boil it down to just zeros and ones? Well, no, there are standards. Okay, so we have to rely on standards. In other words, you cannot have a computer to say, oh, you know what, I'm going to use this particular bit pattern to represent T, and then the printer says, I will look at this bit pattern as T. Because if the printer and the computer disagrees on the standard, then what you think is TOM will print out as something else, because there's no agreement between the computer and the printer. So this means a particular standard has to be used by both the transmitter, the printer, the computer, and the receiver, which is the printer. That standard, used to be, the standard used to be ASCII, ASCII. Okay, so let me just kind of look it up. There you go. So ASCII stands for the American Standard Code for Information Interchange. But what it really, really is saying, okay, each thing that you can print or you want to print on a printer has a binary code associated with it. That's basically all that is. It's a big lookup table. Okay. So if I look at this big lookup table here, you can see one column is designated as char. That's the character that we want to print on the printer. And then on the other three columns, these are all basically different representations of the bit pattern that is used to represent the character. So let's pick specific examples here. Let's look at this particular part. It's basically saying the uppercase T in ASCII code is using 54 as a hexadecimal number or 84 as a decimal number. Okay. Okay. So now at this point, we can take a look at T. Okay. So let me reuse this part here. So you look at uppercase T. According to this, it has a hexadecimal code of 54. So in C and C++, when you represent a hexadecimal number, it starts with a prefix of 0x. Okay, that means that whatever is following is a base 16 number. Now don't worry about what a base 16 number is or how to convert it into binary, because in other classes that will be covered. But in this class, I can do the translation for you. 4 is 0100, 5 is 0101. So that means when this particular bit pattern is transmitted from the computer to the printer understands and say, oh, I want to print the letter T on a piece of paper. Is that okay so far? What about lowercase o, the next letter that we want to print? Well, same thing, you just have to look it up. So O is represented by 6F in hexadecimal, and 6F in hexadecimal translates to, this is 1111, this is 0110. So in order to transmit lowercase o to the printer to print it out, 01101111 is transmitted. So every character that we can print, including punctuations, digits, letters, and so on and so forth, they have their own representation. And that's the agreement between the computer and the printer. Yep.
So there's only 256 possible characters?
Yes.
At the
In fact,
8-bit?
ASCII only goes up to 177. Oh, that actually I take it back. Yep, it does go up. It only uses up to 127. In other words, it's not even using all 8 bits. It's only using 7 bits out of 8. Yep.
27 or 28?
Well, that's because 0 takes up 1 slot. Yep. What about when you press the Enter key? What like on an really old typewriter, there's one lever where you can just slam it. It rolls onto the next line. And the entire carriage also moves back to the home position. What about those things? How do you tell the printer, oh, I want to print Tom on one line, and then Jane, I want to put it on a different line. How do you tell the printer, I want to start a new line?
Carriage line.
It's a new line and then a carriage return. That's why those names are there. Why do you think we have a new line character? It's the rotation of the carriage of a regular typewriter. But just because that thing rotates doesn't mean it moves horizontally, and that's what the carriage return is for. It's carriage return for moving the entire thing back to the home position. And how do you think those things are represented? It's right here. You can see that new line, which is just rotating the cylinder, is represented by 0A in hexadecimal. That's 0000000 1010. Okay, that's the bit pattern to transmit to tell the printer, I want a new line. And if you want the printer to say, oh, I want to start all the way from the left-hand side again, then you have to transmit carriage return, which has a code of 0D. So that's 0000001101. Okay, so even things that cannot be printed, but to control the printer in a certain way, even those things have their own code. Yep.
See that we're converting from the 8-bit to the Uni 16. So there's two systems. There's the American code and then there's the
Unicode.
Universal code.
Yeah.
So is it 16 because everyone else shares that same Chinese,
Right.
Russian?
Yep, exactly. Yep. But for simplicity, we just want to deal with ASCII code for now. Okay, that's just for simplicity. So that means in order to store Tom as a name in an array of characters, we are actually just storing an array of integers. Except those integers have a certain range from 0 to 127, and that's why an 8-bit integer will do the trick just fine. Are we doing okay so far in terms of the representation of things that we can actually print, or names or addresses and stuff like that? Okay. So once we understand this code here, and then we can go back to our sample program. So if I want to store Tom, now one thing you can do is you don't have to actually look up the table, because in most programming languages, if you use a single quote and then a letter and then another single quote, that means you're telling the compiler and say, look up the ASCII code of uppercase T and use that value here. So you don't have to actually look up the ASCII code table, figure out what value it is, and then put it here. But if you want to do it that way, sure, I mean, that's fine too. So if you go to the ASCII table and look up Tom, the decimal representation is 84. So this program would be the same if you just say, store 84 into A bracket 0. That would have stored, the uppercase T as the first letter of this name. Yep.
Now, don't you normally have to say what base your integers are in?
If it doesn't have anything special, like no special prefixes, then it's automatically base 10. That's a standard of C as well. Yep. But if you want to use hexadecimal, then you have to start with 0x.
We didn't define our array to be what integers or anything like that, though.
Hmm?
What type is that? We didn't
It's a
define-
character.
Oh, okay, character, that's what that means.
Yeah. But the character, which is also called a char, C-H-A-R in C and C++, is basically that's basically what it is. It's really just an 8-bit integer.
As opposed to if that was 5 integers, then it would have been different.
If it's 5 integers, then it's by default it's 32-bit. Each integer is 32-bit. So you'll be wasting a lot of space because you really do not need 4 bytes to represent the character. Any other questions? So this is a little bit beyond what my notes already has talked about, but I think it is kind of important because we have to kind of understand how do we store a string. Okay, and this is actually internally how a string of text is actually represented. What about Unicode? What can we represent using Unicode?
Just about any character.
Just about any character of any language, real or otherwise.
I remember seeing they were adding like even characters for dead languages in there.
Not only dead, but also languages that do not exist in real life. So this is a good digression, especially for those of you who like it. Huh?
Like Klingon.
Like
Is it
Klingon, yep,
technically
yep.
an artificial language at this point? Because I've seen a lot of stuff done in it. Too much stuff.
There you go. Yep. So Klingon does take up a portion of the Unicode table. The Unicode table is 16-bit, which means it has 65,536 slots. Okay, and the Klingon alphabet takes up whatever number of characters it needs to take up. So technically speaking, you can have your program to put out stuff in Klingon.
So then this web page would have to have Unicode to decode that, right?
Yes. Now it depends on how this is all done, because if this is a bitmap, then obviously there's no decoding necessary. So you can only tell if see, this is a bitmap too.
The fact that your cursor changes.
Yeah, because my cursor changed to a kind of like a pointed finger. Yeah, I don't think a default.
They kind of figure if you don't have rendering support for it.
Well, it's a font support. Okay, so
Right.
Klingon font test.
I remember I was trying to get like historically accurate.
Oh,
dark.
great.
Red on black background. Why?
And you can learn the grammar of Klingon.
Speak it.
How to speak it.
Dude, oh boy.
Cool. And if you don't have that font, you can always install it too.
What?
Star Trek font, you can even within Klingon you have different Klingon fonts. So I guess these are true Klingon fonts, and then the other ones are not true Klingon fonts. Yep, just kind of interesting. So, but that's taking up places. Now, if you think about it, 65,536 is a lot, okay? Because if you think about Chinese, how many people know kind of something about Chinese characters and stuff like that?
They got like
Okay.
6,000.
5,000.
A normal person who if you just want to be able to read newspaper and stuff like that, I think you only need about 2,000 characters. a scholar may know up to maybe 4,000 to 5,000 characters. So that means 65,536 is a lot. I mean, that's a lot of characters. The big problem with Unicode is, do you have the right font set up in your browser so you can actually, render the characters correctly, based on the language. So that's why sometimes when you look at, web pages, that are intended, as a different language, you also have to make sure that you have the right fonts, already set up. The browser supports it, no problem. Unicode is well accepted as a standard, but whether you have that font already installed is a different question.
Is there a thing where you can just download all of the fonts?
You can probably do something like that. I don't think they would take up too much space. Yep.
Have you tried the Google Translate on some of those other pages? Very interesting.
Very interesting. Well, let's take a look. We're digressing more and more. Okay, it's all right. Okay, now this part is kind of.
digressions. I always learn something.
Okay, this part is interesting because this is also from a grant project that I mentioned earlier in the class. This part of that website talks about how to use a computer for like everyday stuff. Okay, so once again, this is a computer literacy kind of program. It's not really for people like yourself. People in this class really should not need to use this particular website. Okay, but they have translation on this website to Spanish. And if I go to, it pops up right there. This is Google Chrome, so it automatically recognizes that the language of this website is not the default one. And it automatically pops up, this page is in whatever language, and it asks me, do you want to translate it? Which I think is kind of cool in a way, but I have never evaluated the effectiveness. So we'll just go ahead and say, translate.
It's not that it's not accurate, it's literal translation.
Well, welcome to living with. It's called Living with Technology, so it's close. Learn to use computers and the internet with easy to understand lessons that are free to everyone. That's pretty good. I mean, that really is kind of what the English version of the website is saying. The Foundation for California Computer Community Colleges proudly announce establishing. That's the Spanish version, and then this is the English translation. A new program to increase the understanding of the computation and increase access to broadband internet underserved population. So the syntax, the grammar is actually off too. It's not. I think it's a very literal translation.
So you say it's like a B+ translation?
I don't know. I don't know Spanish, so I can't. So this is the original.
Go to Mandarin site and see if you can. I said go to a site in Mandarin.
Or Cantonese.
Yeah.
But it's not bad, okay? I think it's reasonable. Let's see if I have the font set set up here. Apple paper. Yep. So the Chinese character fonts are all supported here. These are all text. I can actually select and copy and paste it. But Google doesn't pop up a translation, offer here.
Right click and see if it says translate. Just right click on the page and see if it translates it.
Is it because you're .hk?
Yeah.
Mine
Is it because you're .hk?
Sorry?
Is it because you're .hk, or does that have nothing to do with it?
No, because each HTML document will specify its own language. So the browser knows natively what is the language used in this document. But it doesn't. Maybe I have answered already in the past. Do not translate, and it just remembers that. So I can only imagine that's the only reason. Yeah, this is saying public servant pretending to be sick, and then the anti-corruption agency arrested 35 people.
That's the same.
doesn't have a translate for that. Yeah.
You can just go to translate.google.com and type in the webpage name and it'll translate it. Like if you go just like the
Yep, it's pretty good. It knows what it is. And that has to do with the Unicode because remember each character has its own Unicode. So by pasting it into Google Translate, it just looks up the Unicode and find out which page it is on, and then it knows what language is the correct setting. Yep. So you can see the translation is literal. Okay. Civil servant play disease fake. So basically, they're faking. They're coughing. And ICAC is actually, this is interesting because this word here is the abbreviated version of the Anti-Corruption Agency of Hong Kong, and it somehow found the exact translation into ICAC. And that part is impressive because that's regional. That is, it's not a literal translation at all.
They work really hard on Google Translate. I've played with
Really?
Google Translate a lot, and they have so many languages. They have Old Latin.
Pretty much every country that they operate in, they have somebody there that does this.
Right, because it's not this part is not mechanical. The other parts may be mechanical, but looking at a phrase and translate the entire phrase to the equivalence in English is not that's not mechanical. Impressive. And that part is kind of impressive.
I'd love to know the number of man hours they put into that.
Now, looking at this, from the perspective of this class, what kind of algorithm would anyone use in order to parse a natural language?
We have some kind of recurring check each entry into their big long list of characters. So you just have to match character 1 to the character in the list.
Well, the first part is what we call lexical analysis. The lexical analysis is simply to look at each, break it up into individual words, which only applies to English and most Western languages, because in Chinese there's no space to separate the characters. Okay, so that's called lexical analysis. Now, after lexical analysis, you now have the individual words. What do you do next with all the individual words?
Search.
You have to look at all the available grammar for a particular language and see how it fits into each particular scheme. So that means, with each word, you have to look up, its place in a sentence. Okay? Some words are nouns, some words are verbs, some words are prepositions, and so on and so forth. So you have to kind of classify, throw all those different words classify those things into their own bins. Now, some words are ambiguous. They can be verbs or they can be nouns. Okay? So in those cases, then you have to kind of look at all the applicable rules and see which one fits better.
And that's why things are usually literal, because it would take so much time to return that particular statement.
They can go through all the possible ways of interpreting a sentence pretty quickly. I mean, that's not a difficult task. So parsing, lexical analysis, easy. Okay, because in English you use space and punctuations to separate different words. So that part is easy. Looking at words to their meaning and their part in a sentence, easy too. Okay. Applying the rules. Okay, this is a sentence, and then you have different parts of a sentence and stuff like that. That part is easy as well. In other words, understanding the structure of a sentence is easy. What do you think is difficult?
Local vernacular.
Well, in terms of translation, what do you think is the most difficult part?
It'd have to be changing the grammar structure so it makes sense.
Okay.
To,
Yep.
Also the tenses as well.
That part is somewhat mechanical too. It's the meaning, because sometimes we have phrasal verbs that can mean one thing or another thing depending on the context. So that part is hard because mechanical translation is what we call context free. Okay, context free means it doesn't depend on what it has read up to this point. It just does something mechanically, okay? And almost all natural languages are context sensitive. In other words, how you interpret the next sentence depends on the context. Yep.
But then you say, like, for instance, even in this one, the original headline, as you read it, was saying, public workers caught faking disease, or public workers faking disease.
Right. Well,
corruption office.
a part of that has to do with the parsing part did not break it up correctly. Now this part here, corresponds to civil servants. Okay, so it does do the association correctly, but what is not correct is these two should be grouped. These two is basically pretending to be sick. Okay, but pretend is also play. Okay, because those two words are actually the same character can mean both. Okay, basically faking and pretending and acting, those are all the same character in Chinese. Even though in English, the word act, the word pretend, and the word fake, they have similar meanings, but at the same time they are also different. But in Chinese, it's a single character meaning all the same thing. So that's why when you read it in Chinese, you have to kind of read both of these at the same time to imply faking.
Because that's context.
Exactly, that's context, and different ways of interpreting things, and Google chose to interpret one word, one character at a time. So it was interpreting this to play, and it is interpreting this one to disease.
You can click the word play to change it. Like it says, click to see alternate translation.
Oh, you mean this one?
No, the
one
English
that's
one.
translation.
Oh.
Oh, they don't even have it.
No, not quite. Of course, you can always get the other one and then get it to translate back into Chinese and see how close it gets to the original. The inverse function kind of thing, the stuff that you guys talked about.
Well, it says play disease fake, right? So like it's faking disease.
Well, but that fake is the other one. That fake is this one. This is the literal word for fake or false. Okay. So it was doing a literal translation with some of the words, but at the same time, it was also catching, characters that actually belong together. These two words together means, ASCII, and they picked that one up just fine.
So what would those be separate?
Huh?
What would those two words that make ICAC, what would those be separate?
Separate?
Yeah.
This means agency. That's all that means. It's just government agency of some kind. This one by itself means humble, or living, simply, with not a lot of things. So it's really, the literal translation would not even come close to what it is.
Government agency.
Yeah, poverty agency or something like that.
The humility agency?
Yeah, something like that. It would have translated it differently. And this is the kind of thing that is kind of at the forefront of computer science, okay? Because it's not really quite there yet. We have some of the mechanisms to do it, but at the same time, it's not complete.
It's still pretty amazing.
On the subject of Star Trek, the universal translator, which is the
I think with technology, we're gonna bypass the translation of language, because if they have an ability to kind of look at what you're thinking when you say something, then it becomes a more universal translation. Because when you think about the color red, then it doesn't matter how you say it. It is still the sensation of that's with the color red. So if they can transmit that information instead of the translation of the word red, then it is a more truthful representation. But it's kind of creepy too at the same time.
But even with just this translation technology, you can infer, except for ICAC, you can infer the rest of what it means. Civil servants play fake disease fake, which means civil servants faking disease in English.
Right.
So the technology already exists for something like that to happen, because there are multiple voiceover language, voiceovers for different languages, like Corsica for English and stuff like that. So if you combine the two technologies, you basically have a universal translator, because they could translate and then read back what it says. It may be literal, but you'd still, most of the time, can understand the meaning.
The only time is when you get into the gray areas.
What is lacking here is the ability for Google Translate to learn. In other words, if they had given another option here, well, they might have it, I just haven't explored it, is to have someone to actually do the translation by hand.
They used
And
to.
over time, they can actually learn from its own mistakes. It's like, oh, okay, I'm making a mistake because I did not interpret these two characters as a whole, and that's why, the translation is not correct. If they can do the automated learning based on feedback from different people,
Speech recognition.
exactly, then it can improve over time without, actually Google having to spend manpower on it, because it's crowdsourcing, right? You're relying on people who are just doing Google search and Google Translate all day long and go, okay, let me help you fix this. Okay, and if enough people do that, then they can learn, and actually do a better job next time.
They used to have that exact feature, but it appears to be gone. I think they may have removed it.
Click on the speaker. It'll say it back.
No, but I think he's talking about, how to fix it, right?
Yeah, like add your own translation. I remember them having that. I remember using it at one point.
Oh, you can rate it. Offensive.
Yeah, if you can rate that feature right there is not helpful.
Okay.
What about on the bottom, it says translator toolkit there, the link?
Let's take a look.
Google Translation memories.
I think that's probably what it is. I mean, because I can have my own selection, and that's interesting. I have never clicked that before. Yep.
You have to use something like that, or there's meanings applied to different words, like sick, just meaning just someone getting a flu or something right now, it's because of different people using it in cool or
Oh, bad doesn't mean bad anymore. Bad means good.
Yeah.
That's what the Urban Dictionary is for.
You know, it's funny that you say crowdsourced translation, because that's what CAPTCHA is.
That's what?
CAPTCHA. You know the CAPTCHA stuff that you enter for